7.8, adding and subtracting radicals. You know, it's easy stuff here, and there's one concept that you need to get in your head that will help this tremendously. And the first thing is, I want you to think about the radical itself as a variable. I mean, if this said 4x plus 5x, we're thinking about this as 4x's plus 5x's gives me 9x's, okay? That's easy, all right? Same thing with radicals. I've got 4 root 7s and 5 root 7s, so when I put them together, I've got 9 root 7s. That's it. Now, one thing you always want to do is make sure that the radical is simplified, okay? And in this case, 7's prime, so it is simplified. There's nothing we can do with it, okay? So that's it. 4 root 7s plus 5 root 7s, 9 root 7s. That easy. Done, okay? Let's look at number 2, all right? Now, in this one, remember, think of these just like terms with variables, all right? I've got 3 root 6s. I've got minus 2 root 13s. And I've got positive 5 root 6s. These are like terms, so I can put them together. That's going to give me 8 root 6 minus 2 root 13. Okay, those two combine to give me 8 root 6, and then I just bring down the negative 2 root 13. Now, these are not like terms, so there's nothing left for me to do. That's it. I could get an approximation using a calculator. I could type in root 6, multiply it by 8, and then subtract from that 2 times whatever root 13 is and get a decimal approximation. But if I want an exact answer, this is as close as I get, okay? And it doesn't say approximate, it doesn't say use your calculator, it just says simplify, and that's as much as we can do, okay? Easy, easy, okay? Now, let's look at this next one. Example number 3, it says simplify. We've got 7 root 3s, negative 4 root 6s, okay, positive 2 root 48s, and minus 6 root 54s. Now, root 3, I know I can't reduce that. I can't simplify that because 3 is prime. Root 6, you should see it, but if you don't, just take a check. Okay, it's root 2 times root 3. That's it. I can't simplify that at all. So I just leave that as root 6. Can't do anything with that, okay? Now, root 48, I'm betting we can do something with that. Remember, it's 2 root 48, okay? So let's break that down. I'm just going to bring my 2 down. Hang on, okay? Just bring the 2 straight down, and then that's going to be root 6 times root 8. That's where I'll go, okay? Now, let's bring down the 2 again. Let's turn that into root 2 times root 3, and let's make that root 2 and root 4, okay? Bring my 2 down again. Root 2, root 3, root 2, root 2, root 2. All right, now I can't break anything else down. Now, I'm going to pair these 2. That gives me 2. I'm going to pair this one and this one. That gives me another 2. Okay, I've got this 2. Okay, and then I've got this root 3 left over. Okay, so that's going to give me 8 root 3. So let's rewrite up here. This is 7 root 3 minus 4 root 6 plus 8 root 3. Okay? 2 root 48 turned into 8 root 3. All right? Now, I'm going to erase this so I'll have that room to work. Okay? Let's go back and see how I can do 6 root 54. So 6 root 54. I'm going to bring down the 6. Okay, root 54, I don't know, let's do root 6 times root 9. Oh, root 6, root 9. Okay, hey, you may see, that's 3. Root 9 is 3, okay, so I'm done with that. Bring down the 6. And then this is root 2 and root 3. I can't break anything else down, right? So here, I'm going to put 3 out here. I'm going to put times 6 right there. And then this is root 2 times root 3. And now I'm going to multiply the things that I can. That's 18 root 6. Okay? Now that's what this is. So now, when I go back up here, I'm going to write minus not 6 times root 54, but 18 times root 6. Okay? All right? That's what that turned into. Okay. Now, I've still got 4 terms. This 7 root 3 and positive 8 root 3 can be put together to give us 15 root 3. minus 4 root 6 and minus 18 root 6 is minus 22 root 6. And that's it. These root 3 and root 6 cannot be simplified anymore. These are not like terms, so that I can't put them together. Done. Okay? Problem simplified. All right, let's look at our last one here and see what we can do with that. James, you got to be proud of me. I'm going fast here, man. Not fast, but this stuff doesn't take a long time. All right? So let's look at this. First thing I'm going to do is I've got root 15, okay? And I can't break that down. I mean, it gives me root 3 and root 5. That's it, okay? And those aren't alike. I can't pair them up. So root 15 is simplified. That's as far as it can go, okay? And then I've got this thing over here, root 3 fifths, okay? All right. Now, remember, I want a common denominator here, okay? And I don't really want to work with, really what I have here is root 15 over 1 minus square root of 3 over 5, okay? Now, I'm going to rationalize this denominator. Remember, we did this in yesterday's lesson. So this is root 3 over root 5, yes? Okay? Multiply the bottom by root 5 and the top by root 5. And I'm going to get root 15 over 5. Okay. That's interesting. So I've got root 15 over 1 minus root 15 over 5. But remember, I've got fractions here, so I've got to get a common denominator. And the common denominator between these two is 5, right? I'm going to put 5 on the bottom. Now, I don't change this one at all. It just stays root 15 over 5. But this one, I had to multiply the bottom by 5 and the top by 5. So now I've got 5 root 15. Now they have a common denominator, so I know when I put them together, it's going to be over 5. But it's 5 root 15 minus 1 root 15, right? There's a 1 in front there, so that gives us 4 root 15. Done. Can I reduce these two numbers? No. If I could, then I should, but I can't. 4 and 5 don't reduce. That's it. Done. Simplified. Now, let's see. I've got a little extra time here. I just want to take a moment and see, what if I did this? What if I just did this? All right? If I had root 15 over 1 and minus root 3 over root 5. What if I said the common denominator was root 5? Okay? Then this would stay root 3. And I'd have to multiply the top by root 5. And then root 5 times root 15 is going to be, what, root 75? Okay? Then I've got root 75 minus root 3 all over root 5. Okay? I need to rationalize the bottom. You see how messy this gets? I mean, I could do it. It works. But this is why we rationalize that denominator. We get rid of it so we have a nice, pretty integer like that. Okay? It makes it much easier for us to simplify things. Okay? So, just forget all of that. We don't want to do that. We want to rationalize, get a common denominator, and then put them together. All right? That's our answer. Good job, guys. You're ready. I don't think there's anything else for me to tell you. Get to work.